I'm working on Cycads, and I'm particularly interested in answering on one question, and with Cycads. And the question is, what forces or what evolutionary event might have shaped the diversification pattern of Cycads globally? But before I got into the detail of the question, just a little bit of background about Cycads. Cycads, we have about 340 species, some say 345 species, but we have 10 genera, but I will specifically be talking about 3 of them. The genus Encephalatus that I'll be referring to as the African cycad. We have about 65 species of them. I'll also be talking about the genus Cycads, which is about 112 species. The last genus I'll be talking about is the genus Zamia, which is about 75 species, and I'll be referring to the genus Zamia as the American cycad. In this map over there, you see the distribution, the geographic distribution of cycads worldwide. You will never see cycad in temperate climate. You see them only in tropical and subtropical region. The question that I'm interested in is actually not something new in Cycad. In 2011 already, Nagalingom has already published this paper here in Science, where they actually reported 2 key take-home messages. The first one is that the Cycad group are actually much younger than we traditionally thought. They are not 300 million years of age, they are only 12 million years of age. And that is the first key message in that paper. And the second message in the paper is that the diversification of Cycad is actually climatically mediated. And the approach that they use in that paper is that they use a global perspective. And I believe that the global perspective may actually mask some important information that may have happened at the local scale, for example, at continental level. And 3 years later, I actually published this paper. And the best point to start with when you are based in Africa is to look at what's going on with the African cycad. And when I mentioned African cycad, I actually mentioned the genus Encephalatus, 61 species. And the paper said that provide an evidence of constant diversification punctuated by a mass extinction in the African cycad. The constant part of the story is actually boring, but the most important part is what happened, the punctuation, the punctuated event that might have happened. And that's what I'm gonna report here in the next slide. If you have this phylogen over there, is the complete phylogen of the African cycad that we assembled, and 64 species, 4 markers, and you see a clade here in red, and you see next to it fastest speciation rate. And the question, which means that the diversification across the phylogeny is actually heterogeneous. And the question is why? What happened? Why this particular clade underwent a rapid radiation? And to answer the question, we reconstructed what we call the LTT plot. And when you look at the plot, you will see around 2.6 million years ago, there is a sudden shift, right, in the speciation rate. And when you look at that period, actually corresponds to the Pliocene-Pleistocene transition. And when you look what the environment looked like in Africa, and particularly in Southern Africa, it corresponds to an arid environment. And when you come back to this clade over here, all the species in this clade are endemic to Southern Africa, particularly to South Africa. And when you look closely into the species in that particular clade, none of them has an above ground stem. They all develop underground stem in this particular clade. And when you link both, you link an arid environment with the development of underground stem, the third thing that you can think of is perhaps the development of underground system is perhaps in response to the arid environment, like a survival strategy, an adaptive strategy to survive the harsh environmental condition in that particular period. And if that's the case, then the development of underground system that you only find in this particular clade may be regarded as a key innovation, right, in the African cycad. So, but there is a further study that uh, explore why or how species went underground. And this paper was published in 2014, and they dig more into what may have driven the development of underground system. And what they reported here is that fire has something to do with the development of underground system. Where you have high frequency of fire occurrence, you are more likely to find these underground system. This work has been a little bit controversial because think, for example, question the importance of fire in driving the underground system, and they actually advocated for force rather than fire. And there has been a response to their work where we actually acknowledge that, yes, force might be important, but it cannot be only force. And recently, in May this year, there is also this group who also work on the same system, and they actually say, yes, force might be important, but fire is the most important driver of underground system. So this is my first story. I have 3 stories to tell. This is the first story about the African cycad. The story number 2 is on the genus Cycads, which is endemic to Pacific Island, from the northern Asia down to northern, for the southern Asia, sorry, down to northern Australia, and including all the island in between and westward to East Africa, and including Madagascar. They published this work in 2015, where they actually work on the historical biogeography of the genus Cycad. But I have 2 major concerns about the publication. The number 1 is that in the group we have 112 species, and they only included 31 species in the analysis to infer the potential historical biogeography of the system. And we revisit actually the work that they did by assembling a more complete phylogeny. This over here is the phylogeny that they use. Yeah, it looks like it's more than 31 species, but it's actually 31 species. You have a lot of replicate in the analysis. So this is what we reconstructed. I must highlight here that this work is still an ongoing work because it's not published yet. We're still working on it, and we try to improve the phylogeny. I have a discussion with Yanis on this story. Apparently in their lab, they're still working on phylogeny, but this is what we have. A more complete phylogeny, 112 species compared to 31 species that they use, and we use exactly the same model that they use for reconstructing the historical biogeography of the group. So over here is what we are reporting. We identify Indochina as the origin of the genus Cycads, and this origin is dated back to 7 million years ago. And we think that Malaysia has been first colonized, and from Malaysia, right, the rest of the distribution range of the genus has been colonized, and it is at the later stage that South China has been colonized. But in their work that they published in 2017, they actually indicated that South China is more likely the origin of the genus Cycads, and first the Indochina has been colonized, and from South China, the rest of the distribution range has been colonized. Someone must be wrong, someone must be right in these studies, but we think that we're right because for 2 main reasons. One, we use a more complete phylogeny, and number 2, how they identify, how they determine the sequences in the colonization process was not clear in the paper. It was just a claim that was not really substantiated by any of the analysis that they did, unlike what we did in this analysis, because based on the origin, the evolutionary age of the different clade in all this region, we infer this sequence in the distribution range. So 2 months ago, I was in Nimbarus, the National Institute for Mathematical and Biological Synthesis in the University of Tennessee for a workshop organized by HONA, and the objective of the workshop was to learn a new approach to reconstruct the evolutionary history of diversification using a Bayesian approach. So for Cycads, for the genus Cycads, we apply this Bayesian approach, and this is the result, what the result look like. Here you have the dynamic, the temporal dynamic of the speciation. Over time, you find here an increase followed by a plateau and a decrease in the speciation rate. Here you see a number of bars, of vertical bars. Each bar represents an evolutionary event. And specifically here, it corresponds to a speciation event. And the significant level is actually measured by the 2 times the logarithm of Bayes factor. If that is higher than 6, it should mean the evolutionary event is actually significant. And what you see here is the increase that you see here over here is actually the only significant speciation event that may have occurred in the diversification of the genus. You have multiple other speciation event, you have multiple extension event, multiple mass extension event, but none of them were significant. But the question is, these unusual diversification speciation here may have be driven by what? In the genus Cycads, we have 6 sections, and what we look at is the section of Amphiae here is the section that actually underwent this unusual speciation event. And what is special about the genus, about this section of Amphiae? You have a spongy undercarp in this clade that you don't see anywhere else along the phylogeny, and this spongy undercarp may have facilitated a flotation of the seed, and with a number of sea level rises across the Pacific Island, in combination of the flotation possibility, this might help in a long distance oceanic dispersal of the species from South Asia across the current distribution range that we know. Now, the third story that I want to tell, and that will be the last for the diversification history, it is on the genus Zamia. This genus is what I call the American cycad. You have them in the northern, South, and Central and South America. And you have about 75 species. And we apply the same Bayesian approach to reconstruct potential evolutionary events. And you see here the speciation is actually decreasing from the start toward the tip. And you have here somewhere around 2.5 or 3 roughly species per million years, and decreasing up to around one species per million years. And that decrease is actually the only significant shift in the speciation that we observe. Again, multiple speciation, multiple extinction, around 2 max extinction events, but none of them were significant. Now, how do we explain this pattern? If you look at the distribution, if you go to the genome size, there is a gradient in the genome size from the north to the south. You have small genome size in the north, and you have small genome size in the north, and you have a larger genome size of the species in the south. But you have the exact opposite when it's come to speciation rate over time. You have a low speciation rate here and a high speciation where the genome size is small. And that makes us think of a potential role of the genome size in the diversification event. This is not new. It has been shown at several occasions, but it's not universal because an exact opposite of the potential role of genome cell has also been reported. So we're not 100% sure of what is the contribution of genome size in driving diversification. So the last part of the presentation is on the conservation story. I published with my student this work this year in the AOB plan, where we try to summarize what are the factors driving the extinction risk in Cycads. I must mention here from the beginning, here you have the distribution, the proportion of Cycad species across the IUCN category. All of them put together, you have something like 70% of Cycad species are threatened with a high risk of extinction. And here you have a summary of all the threat, from habitat loss to invasive species, and in between you have fire, you have grazing, you have reproduction failure, and you have invasive species. These are some of the threats that we find. And here are some correlates of the extinction risk, and these include the geographic range, the altitude, the maximum height, and the diversity of threat. What we mean by diversity of threat is the total number of threats that a particular species is facing. Now, the question is, if 65 species, 70% roughly of Cycad species are threatened with a high risk of extinction, how this will impact the evolutionary diversity accumulated on the Cycad tree of life. So this is part of the key messages that we put across in this paper that we published also this year in Ecology and Evolution. But before I got into the detail of that question, I just want to go very briefly into the literature and look at what has been reported for vertebrate. And here is a paper in 2014, I think, on bird, where they tried to look at the correlation between IUCN threat category and ED. ED is evolutionary distinctiveness, and they reported no correlation between IUCN and the ED category, which means if we lose threatened species, we're not sure how this will impact on the evolutionary diversity. And similar study was also done on mammal, where they reported similar finding that if we lose threatened species based on the IUCN category, we're not 100% sure of what's going to happen to the evolutionary diversity. And recently, I think last year on reptile, similar studies, similar finding reported. And we come in with the Cycad story. Of course, we cannot compare, it does not make sense to compare animal or vertebrate and plant, but it can give us some insight into how spatial Cycad are. So this is what we reported for Cycad. We report exactly the opposite of what has been reported for vertebrate. We have a positive correlation between IUCN category and the evolutionary diversity, which means that if we lose highly threatened Cycad species, we risk losing more diversity than expected. And this is exactly what we reported here. If this is the pattern for vulnerable species and endangered species, if we lose one endangered species or vulnerable species, we won't lose more diversity than expected. But if we lose the critically endangered species, we will lose more genetic diversity than expected. And this is actually a support to those who are fighting for the preservation of threatened species. If it preserves highly threatened Cycad species, at the same time you are preserving the evolutionary diversity in the Cycad tree of life. And finally, we map the different hotspots, the different diversity hotspots of Cycad using different metrics, from species richness to phylogenetic diversity to species endemism and phylogenetic endemism and age. And here is a combination of all those hotspots. I'm not sure if it is clear from far, but you will see that Southern Africa is actually the most important hotspot when you combine all those 5 hotspots together, which means that the preservation of Cycad actually should start from Southern Africa. Of course, in Australia and part of Eastern Central Africa and the America. So in summary, the diversification of Cycad is actually mediated through multiple evolutionary events For encephalitis, for example, you have something happen around 2.6 million years ago. You have the development of the key innovation, which is an underground system. If you look at what happened for the genus Cycads, you have the development of another key innovation, in this case, a spongy undercarp. You have multiple sea level rises that might contribute to the long oceanic dispersal of the species. And you have, for the American Zambia, you have a decrease in the diversification through time. And for conservation perspective, the Southern African hotspot is perhaps the most important if we have to preserve the evolutionary diversity, right, of the cycad. And if we lose highly threatened cycad, we risk losing more genetic diversity than expected. So I would like to thank all these institutions that have contributed in one way or another in the kind of study that I'm doing. Thank you very much.
Could you please return to the last slide? You announced here, I'm sorry. You announced here that 3 million sponge endocarp multiple sea levels rises and the long dispersal. I guess that not sea levels rises, but sea levels depression may cause this because they may use land bridges for migration. Am I right?
I actually thought of the opposite. The sea level rises will actually facilitate the dispersal.
So that is the border for terrestrial animals.
Yes.
So how the Cycads may move through the water.
Yes, I will think of it.
If the water level depressed,
yes,
follow down, then the bridge occur, terrestrial bridge for land animals to move. Is it right?
No, land animal. This is not animal. This is plant.
That is, doesn't matter. That is a plant or Cycads. Cycads, what is it? That is insect.
No, cycad.
Anyway, how they move through the water.
No, I'm talking here about long oceanic dispersal.
Okay, I'll later.
Okay, thank you.
More questions for Kowiyou? Okay, just one. Oh, there's one there.
Oh, Yanis. Toujours Yanis.
So I was just wondering on the diversification models you run, on the phylogeny, if you had signals of extinction through time. What about the extinction rates? Did you have increases in the past or no? I'm just wondering about, just what kind of diversification models you applied, if it's birth-death, and it at some point along the phylogeny you would have significant increase in extinction rates in the past.
Yes, we found multiple extinction events, but none of them was significant. And what time?
Yeah, more or less when.
Oh, I mean, it will depend on the genus we're talking about. Sorry. For this, these are the different extinction events, and it's actually throughout the diversification period.
So you don't have one particular geological period in which.
No,
okay.
No.
Just thinking about mass extinctions for cycads in the Cenozoic. That's why.
Yeah, but no. In this case, this is for Zambia, and you have a multiple extinction period throughout. But none of them was significant, and this similar pattern for the other two genera that I mentioned.
Okay. Thank you.